Imagine this. A star, millions of times bigger than our sun, meets its end in a violent explosion. What happens next? Could that force reach us here on Earth? What if the universe is far more dangerous than we ever thought? Now picture this. 2.5 million years ago, in the distant Andromeda Galaxy, a massive star died in the most dramatic way possible. Its last moments unfolded in a massive explosion that ripped through space, releasing an unfathomable amount of energy. The nearest planets vaporized in an instant, leaving nothing but dust. But here's the real question. What does that mean for us? Could something like this happen in our galaxy? Could our planet be next in line? As this cosmic event sent shockwaves across the universe, it triggered a powerful electromagnetic pulse, spreading outward in all directions. And guess what? That pulse has been traveling through space for millions of years, and it's heading straight for Earth. How much do we really understand about the forces shaping our universe? Are we just tiny specks in the path of unstoppable cosmic destruction? What will happen when this energy finally arrives? Can we ever answer these questions? Well, we'll have to keep watching to find out. Galaxies are massive collections of stars, planets, and other celestial objects that make up the universe. Our galaxy, the Milky Way, is where we live. But it's not alone in space. The closest major galaxy to us is the Andromeda Galaxy, also known as M31. The Andromeda Galaxy is a spiral-shaped galaxy with a central bar of stars, and it's the nearest large galaxy to ours. It was once called the Andromeda Nebula and is cataloged as Messier 31, M31, and NGC 224. Andromeda is about 152,000 light-years wide and sits about 2.5 million light-years away from Earth. Its name comes from the constellation Andromeda, named after a princess in Greek mythology who was married to Perseus. It was mentioned as early as 965 CE in the Book of the Fixed Stars by the Islamic astronomer Al-Sufa, and rediscovered in 1612, shortly after the invention of the telescope, by the German astronomer Simon Marius, who said it resembled the light of a candle seen through a horn. For centuries, astronomers regarded the Andromeda Galaxy as a component of the Milky Way galaxy, i.e., as a so-called spiral nebula, much like other glowing masses of gas within the local galactic system, hence the misnomer Andromeda Nebula. Only in the 1920s did the American astronomer Edwin Powell Hubble determine conclusively that the Andromeda was in fact a separate galaxy beyond the Milky Way. The Andromeda Galaxy has a past involving collisions with and accretion of other galaxies. Its peculiar close companion, M32, shows a structure that indicates that it was formerly a normal, more massive galaxy that lost much of its outer parts and possibly all of its globular clusters to M31 in a past encounter. Deep surveys of the outer parts of the Andromeda Galaxy have revealed huge, coherent structures of star streams and clouds, with properties indicating that these include the outer remnants of smaller galaxies eaten by the giant central galaxy, as well as clouds of M31 stars ejected by the strong tidal forces of the collision. According to NASA, Andromeda is about 260,000 light-years wide, making it the largest galaxy in the local group. However, its mass is roughly comparable to, or even less than that of the Milky Way. Scientists think the galaxy could be anywhere from 5 and 10 billion years old. However, it may not have existed in its current form until 2 or 3 billion years ago, when two smaller galaxies orbiting each other merged to form the current Andromeda Galaxy. Andromeda is visible to the naked eye, but only when viewed in dark skies and ideally on a moonless night. In many places, it is visible the entire year, for at least part of the night, but is highest in the sky, and therefore easiest to spot in August and September, according to Earth Sky. There are several ways to find Andromeda. One of the easiest is to locate the constellation Cassiopeia, which forms a kind of M or W shape in the sky. The lowest point of the W is the star Shadar, which points directly at Andromeda. Using a high-powered telescope in dark skies, it is also possible to observe some of the star clusters within the galaxy, such as the bright cluster Male 2, also called Globular 1 or G1. This cluster is so bright that some researchers think it is the remnant of the core of a dwarf galaxy that merged with Andromeda in the distant past. The Andromeda Galaxy, located approximately 2.537 million light-years from the Milky Way, serves as a crucial reference point in our understanding of the universe. This distance is immense. For perspective, 1 light-year equals about 5.88 trillion miles, 9.46 trillion kilometers. In cosmic terms, Andromeda is relatively close, making it a key subject for studying galactic formation and evolution. It is on a collision course with the Milky Way, expected to merge in about 4.5 billion years, providing insights into the dynamics of galaxy interactions. Additionally, Andromeda contains over 1 trillion stars and numerous exoplanets, offering a glimpse into the structure and variety of galaxies beyond our own. Understanding such distances also highlights the vastness of the universe and our place within it, emphasizing the challenges of intergalactic travel and exploration. When the Milky Way and Andromeda merge in about 4.5 billion years, they will probably form a huge elliptical galaxy. Chances are that our solar system will be relatively unaffected. We might be pulled away from the center of the galaxy, or we might be totally ejected from it. Stars are so far apart that any sort of collision is extremely unlikely. However, it's almost certain that the increasing luminosity of our Sun will have caused Earth to become inhospitable to all multicellular life by this point, so we will not be around to find out. Studying Andromeda helps astronomers learn about the formation and evolution of spiral galaxies, offering insights into the processes that shape galaxies. As part of the local group of galaxies, Andromeda's interactions with the Milky Way and other nearby galaxies provide a unique opportunity to study gravitational interactions and the dynamics of galaxy clusters. Observations of Andromeda's rotation curve contribute to our understanding of dark matter, helping to refine models of its distribution and influence in galaxies. Comparing Andromeda to the Milky Way allows for a deeper understanding of galactic features, star formation rates, and the presence of different stellar populations. Overall, Andromeda serves as a crucial reference point for research into galaxy evolution and the broader structure of the universe. Andromeda's trajectory makes the Andromeda-Milky Way collision inevitable. The collision between the Andromeda Galaxy and the Milky Way, expected to occur in about 4.5 billion years, will be a dramatic event. Here's what will likely happen. 1. Initial approach. Andromeda is currently on a collision course, moving towards the Milky Way at about 110 kilometers per second. As they approach, gravitational interactions will begin to influence the structure of both galaxies. Second, merger process. The galaxies will pass through each other multiple times, causing significant gravitational disturbances. Over the course of about 2 to 3 billion years, they will merge into a single larger galaxy, often referred to as Milkomeda, third star interactions. Despite the massive number of stars, the vast distances between them mean that direct collisions between stars will be rare. However, the gravitational effects will trigger new star formation in gas clouds. 4. Galactic structure changes. The merger will result in a redistribution of stars and gas, likely leading to the formation of a new galactic structure, such as an elliptical galaxy. 5. Supermassive black hole dynamics. The supermassive black holes at the centers of both galaxies will eventually merge, likely emitting gravitational waves. 6. Long-term outcome. Over billions of years, the resulting galaxy will stabilize, leading to a new equilibrium in its structure. While this process will be cataclysmic on a cosmic scale, the vastness of space means that individual solar systems, including ours, will likely survive the encounter. Measurements of the Doppler shift of the Andromeda Galaxy's spectral lines indicate the galaxy is getting closer to our own. But such measurements can only tell you about the motion directly towards or away from the observer. Working out if we were in for a direct hit or a near miss required careful study of the motion of Andromeda's satellite galaxies. Plugging this information on the relative velocities, estimates of the masses of the galaxies, and details of their structure into their model. The authors of an interesting paper on this galactic collision have watched the event unfold. Though the details depend to some extent on galactic structure, and in particular on assumptions we make about the halos of dark matter that contain the visible disks of the Milky Way and Andromeda, the general picture is clear. After a spectacular series of close passes lasting billions of years, and which will distort the structure of both galaxies, a final merger of the Andromeda Galaxy and the Milky Way galaxy will occur about 10 billion years from now. Closest galaxy to the Milky Way is estimated to contain 1 trillion stars, roughly twice the number in the Milky Way, and spans about 220,000 light-years in diameter. Despite its size, Andromeda and the Milky Way are similar in several ways. Both are spiral galaxies, possessing a flat, rotating disk of stars and gas, a central bulge, and spiral arms. These structural similarities have made Andromeda an object of particular interest, as it provides a comparative model for understanding the Milky Way. Here comes the big question: is Andromeda bigger than the Milky Way? The Andromeda Galaxy is generally considered to be larger than the Milky Way galaxy in terms of both mass and diameter. In terms of mass, recent estimates suggest that Andromeda has a mass roughly 1.5 to 2 times that of the Milky Way. These estimates are based on various observational data, including the dynamics of its satellite galaxies, the velocities of stars in the galaxy, and the distribution of dark matter. However, it's essential to note that these estimates have uncertainties, and the mass ratio could change as more precise measurements become available. In terms of diameter, the closest galaxy to the Milky Way also exceeds the Milky Way. It has an estimated diameter of about 220,000 light-years, whereas the Milky Way has a diameter that ranges from about 100,000 to 160,000 light-years, depending on how one measures the galaxy's extents, including its diffuse outer halo. Additionally, Andromeda contains more stars than the Milky Way, with estimates of around 1 trillion stars compared to the Milky Way's 100 to 400 billion. If we consider a hypothetical journey to the closest galaxy to the Milky Way, the Andromeda Galaxy, using current technology, the time frame is staggering. The fastest human-made spacecraft, the Parker Solar Probe, travels at speeds of about 430,000 miles per hour. Even at this pace, it would take an estimated 6.9 billion years to reach Andromeda. While theoretical advancements like warp drives suggest faster travel, these concepts remain speculative and far from actualization. The Andromeda Galaxy exhibits a fascinating contrast to the Milky Way in its stellar populations. The halo of the closest galaxy to the Milky Way contains a higher proportion of metal-poor stars, offering insights into the divergent paths these galaxies have traversed through cosmic history. As we said earlier, one inevitable aspect of being the closest galaxy to the Milky Way is that Andromeda is on a collision course with our galaxy. Predicted to occur in about 4.5 billion years, this event will significantly alter the structures of both galaxies, likely resulting in a new elliptical galaxy. The proximity of the Andromeda Galaxy has been a boon for astronomical study. Advancements in telescopic technology, from Edwin Hubble's initial observations to modern initiatives like the Panchromatic Hubble Andromeda Treasury PAT, have deepened our understanding of both Andromeda and broader galactic phenomena. The Andromeda Galaxy provides insights into galaxy formation and evolution, especially regarding how spiral galaxies interact and merge. Observations of M31 help astronomers understand the dynamics of large-scale structures in the universe and the fate of our own galaxy. Overall, the proximity and characteristics of Andromeda make it a key focus in understanding our cosmic neighborhood. The impending collision between the Milky Way and its closest galaxy, Andromeda, transcends scientific discourse and seeps into socio-cultural conversations. The event serves as a catalyst for contemplating existential questions about humanity's place within the universe and the scientific strides that might allow future generations to navigate such significant cosmic changes. The Andromeda Galaxy, being the closest spiral galaxy to the Milky Way, serves as both a cosmic mirror and a yardstick for understanding galactic phenomena. Its proximity allows for detailed studies that deepen our comprehension of galaxies, cosmic evolution, and perhaps even the future of our own galaxy. The relationship between Andromeda Galaxy and the Milky Way is a complex tapestry of kinship and destiny, spanning both distance and time, and is continually being enriched by new scientific discoveries. The Andromeda Galaxy serves as a vital cosmic yardstick for understanding our own galaxy, the Milky Way. Its proximity allows astronomers to study galactic dynamics, stellar populations, and evolutionary processes in detail. The impending collision between Andromeda and the Milky Way not only offers insights into the future of our galactic environment, but also emphasizes the vast timescales and intricate relationships within the universe. This merging highlights the interconnectedness of galaxies, prompting reflections on the nature of cosmic change and the resilience of celestial structures. Ultimately, Andromeda acts as a mirror, allowing us to gauge not just the physical characteristics of galaxies, but also our place within the grand tapestry of the cosmos, inspiring both scientific inquiry and cultural imagination. Thanks for watching this video, and see you next time.